Hello, good afternoon, students. Am I audible?
Yes, sir. Good
Good
afternoon,
afternoon.
sir.
Sir.
Okay, so for 35 students who have joined, let it be. So we shall now start. I hope the presentation screen is visible to all of you, entitled Behavioral Modeling 2. Is that visible? Okay.
Yes,
Yes,
sir.
So,
sir.
yeah. So, in the morning, we have discussed various statements, rather the constructs of VHDL, and later on we started with the statements specific to the behavioral modeling. So the most important constructs of VHDL are the entity construct. So with the entity, you define an entity, the black box for a particular circuit. The entity specifies the interface for that particular circuit, that is what are its inputs and what are its outputs. So that is the purpose of the entity, whereas the architecture statement is going to specify the functionality of a given entity. So in any VHDL program, you must have these two constructs. First one is the entity construct and another one is the architecture construct. The entity construct is not going to specify the functionality of the circuit. It only specifies the interface, what are the inputs and what are the outputs, whereas the architecture construct is going to specify the functionality of the given entity. Okay. We discussed various statements with respect to the behavioral architecture, and one of the important statement or construct is the process construct. So, in the process construct, we write the statements, and those statements which are written in the process construct, they are purely sequential statement. They are executed uh, one after another. Whereas if we do not write the process constructs, in that case, it will be concurrent execution of the statement which are given in the architecture construct. Okay. Now we shall move forward with the statements of VHDL. We shall consider if then else next for statement, the other looping statement also in this particular topic. So first of all, the if statement. Now the topics that we are going to see, which contains the constructs or the statements which are very similar to that of the C language. So as far as understanding of these particular statements are concerned, because you are already using this particular, you are already acquainted with the C, what you need to do is that you have to just check what is the difference in the syntax, because the syntax is not exactly same, though it is very similar to that of C, but it is not exactly same as that of the C. So you may be writing the if then else statement in the C, but here in case of VHDL, if then else exists, but the syntax is little bit different. So what are the differences in that syntax, so that you need to notice, and accordingly you should be able to write the if then else statement in the VHDL. Okay. So the if statement, as you know, selects a sequence of statement for execution based on the value of the condition. So in the if statement, we specify a condition. the value of that particular condition will be either true or it will be false. So it is a Boolean value and it will be either true or false, or in case of bit it will be 0 or 1. If it is 1, then the part which is there in the then will be executed, otherwise the part which is there or the statement which are there in the else are to be executed. So the general form of the if statement, okay, considering the nested if else statement, it can be written in this particular fashion. If is the keyword that is used in this particular uh, VHDL. Okay, like you have the if statement in the if statement in C also. Okay, if keyword in the C also. Okay, then you have to write the Boolean expression. Okay, so the value of this particular expression will come out either to be true or it will come out to be false. Okay, then followed by this, you can immediately write the sequential statement, and these statements will be executed only if this particular condition is satisfied. Okay, then optionally you can write another condition, else if. Okay, so this is the change in case of VHDL. So else if is not there in case of C. If you want to implement this, then you have the nested if statement, and you can use that particular state, another if statement, and with that you can check another condition. But here in the single if statement, here you have the feature of specifying another condition. That means if the first condition is not satisfied, then you can go for checking another condition if you have another condition, and then another condition can be specified, and if this condition is satisfied, then this particular statement will be executed. Okay, of course, because this is written in the square bracket, that means writing else if is optional. So in the case if you want to write only this particular statement, that is if some condition is satisfied, this statement is to be executed or not to be executed, otherwise no statements are executed. So directly after this if, you can go for writing the end if. Okay, so if in between any conditions are there, if more number of conditions are there, then you can repeat this particular part, okay, as many times as it is required, this particular else if part. Okay, so you can the part which is encircled, so it can be repeated any number of times. So like that you can nest the if statement. Finally, when the last condition, even if the last condition is not satisfied, and in that case if you want to execute some statement, then that statement can be written after the else. So for else you don't need to specify any condition. Okay, so if no above conditions are satisfied, then this particular sequential statement can be executed. Again, writing of this else is also optional. If you do not want to have this else statement, then that is also permitted. Okay, but at the end of this particular construct, you must write end if. Okay, so for every if, it must be enclosed by the corresponding end if. Okay, so this is how is the format of the if statement. So let us now see the example of the if statement. So this is one example of if statement. So what is it? If is the keyword, then what is the condition? The condition is sum is greater than or equal to 100. If sum is it is less than or equal to 100, then uh, this particular statement is to be executed. That is, sum is equal to sum plus 10, and here the end if statement is written. That means this particular end if is going to finish here itself. Okay, so this is one if statement. Okay, so this particular part is one if statement. Okay, then here starts the next if statement. If the nickel in then deposited is less than or equal to total 10. Okay, so if this is the condition, then in fact this particular nickel in itself is a Boolean variable. Okay, so it is specified by using Boolean variable. So here if that the value of nickel in it is 0, then it will not be executed. If the value of nickel 1 is nickel in is 1, then this particular statement is executed. That is deposited is equal to or is assigned, deposited signal is assigned total 10. Okay, then else if is there, that means if that condition is not satisfied, then dime in is another Boolean variable and its value will be either true or it will be false. Then here it will be deposited will be assigned total 15. Else if again there is another Boolean variable, that is quarter jn. If it is true, then deposited will be assigned total 30. Else, okay, if none of these three Boolean variables are 1, then it will reach this else, and then deposited will be assigned the total error. Okay, so this is how this particular second. So this is the second if statement. Okay, so two if statements they are over up to this. Okay, now the third example is given here. If CTRLI is equal to 1, then again the nesting of if statement is done here. Okay, so this is the outer if then else statement. Okay, for if then this is the else part of this particular if. Okay, and this is the end if of this particular if. Okay, then in this particular if statement there is again another if then else statement, that is CTRL2 is equal to 0, then the mux output is this much. Mux out is assigned this value 0010, else the mux out will be assigned the value 0001. So this is the end if of this inner if statement. Okay, then again another if is there. If CTRL2 is equal to 0, then the mux out is assigned 1000, else the mux out will be assigned 0100, and this is the end if of the inner if. Okay, whereas this is the end if of the outer if. So like this it is possible that you can nest the if statement in the VHDL. Okay, so the syntax is very similar to that of the C, but little bit differences are there, so that you need to note. Now this is one complete example. This is one complete program for a 2-input NOR gate. Okay, so a 2-input NOR gate. So we write a program to implement a 2-input NOR gate. So for that purpose, we write the entity statement, okay, or entity construct. So entity name that we have given to this particular entity is NOR2 because it is having 2 inputs. So the name given is NOR2. Okay, then it is the part of the syntax for the entity statement. Okay, then in the entity statement we define input and output. So that is done with the help of the port clause in that. Okay, so in the port we write A comma B. So A comma B, they are the inputs. So after that we have written this colon. In it specifies that they are of input mode, and its type is bit. That is, it will take the values 0s and 1. Whereas Z is the output. So after colon out is written here, and its type is again bit. Okay, and then we write the end of that particular entity NOR2. Okay, so this is the this is the entity. Okay, for example, you may be having the NOR gate like this. Okay, so the symbol uh, for the NOR gate, sorry, this is going to be exclusive OR gate. uh, I will draw it here, the symbol for the NOR gate. So it is the OR gate with the NOT gate in front of it, okay, or bubble. So this is the NOR gate. So it is having two inputs. The first is A input. It is difficult to draw or write using mouse. So A and B are the inputs, whereas Z is the output of this. Okay. So this is how what is described. Okay. So actually your entity, it is inside this particular black box. Okay. So what is there inside, it is not specified by using the entity statement. What are the inputs and what are the outputs, that is only specified using this particular entity statement. Okay. Whereas the architecture statement is there, which describe the functionality of this particular entity. Okay, so we define the architecture NOR2. Okay, of NOR2, you can use the same name as that of the entity name. Okay, or if you required, you can give different name for the architecture. Okay, here the same name is given, so that is valid. Then we write the architecture, the begin for the architecture. So here the architecture starts. Now because we are here working with the behavioral modeling, so every behavioral modeling program, it contains this particular process statement. Okay, so the process statement is there. So if we write process statement, then the statements inside the process statement, they are executed sequentially, that is one after another. That is the way the statements are executed in the higher level language program. Okay, so the process is written here. Then we write the inputs to this particular process. So A and B are the inputs to this particular process. That is, this is the rather it is called the sensitivity list. Sensitivity list in the sense that if any of this A or B changes, okay, so that is if A changes from 1 to 0, or B changes from or A changes from 1 to 0 or 0 to 1, or B changes from 1 to 0 or 0 to 1, then the execution in this particular process will start. Then this is the declaration part. This much, these three statements, they are the declarations. So two constants have been declared here. The first constant is rise time of time, and it is 10 seconds. The second constant is fall time, and its time is and its value is 5 nanosecond. Whereas the third is the variable, and it is temp variable of bit type, and it has not been initialized. Okay, then when the execution starts, so for the first time these statements will be executed, and they will be executed subsequently when the value of A and B changes. As and when they are they change, these statements are executed repeatedly. Okay, so what happens as a result of this? Temp is assigned A nor B. Okay, so nor is the operator, inbuilt operator that already you have in VHDL. So we write temp is equal to temp is assigned A nor B. Then if temp is equal to 1, then Z is assigned temp. Z is assigned temp after a rise time. Okay, so how much is the rise time? It is 10 nanoseconds. So it is equivalent to writing Z is equal to temp after 10 nanosecond. Okay, so immediately you are not assigning temp to Z, but you are assigning it after 10 nanosecond. Else Z is assigned temp after fall time, that is 5 nanosecond. Okay, that means here we are also defining at after how much time the output should change. Okay, so if it is the usually that particular rise time is high, higher than the fall time. Okay, so if temp is going to be high, that means if the value of output is 1, is going to be 1, then in that case the rise time is 10 nanosecond. That means the z, the value of z is to be changed from 0 to 1, and it will be changed after 10 nanoseconds. Whereas if the value of z is already 1, and now the new value which is going to be assigned to z is going to be 0, then in that case it is falling. So fall time is 5 seconds. So after 5 seconds z will be 0. Okay, after 5 seconds of what? After 5 seconds of a or b have been changed. After 5 seconds of a and b have been changed, this is evaluated, and z will be assigned that value. That means immediately after a changes or b changes, z will not change. Z will change either after 5 seconds, or z will change after 10 seconds. If it is rising, if the z is rising, it will change after 10 seconds. If z is falling, then it will change after 5 nanosecond. Okay, so here we have not only implemented NOR gate, but we have specified the delay for the delay between the input and output of this particular NOR gate using this particular process statement. Okay, so if statement we are going to use in this case for the purpose of checking whether temp is equal to 1. Okay, so like that we can use if statement or the other statement inside this particular process statement. Okay, because the statements in the process, they are executed sequentially. That is why we can write the if else and if statement inside the process statement. Okay, without without process, it is not possible to write the if else and end if statement. Okay, so that point need to be noted. Okay, now the next statement with the VHDL is the case statement. Okay, like in the higher level language you have the case statement. So in the similar fashion you have the case statement in the VHDL also, but the syntax is little bit different. The syntax is like this: case, then expression. So this is the expression, and is. So the switching happens between based on this particular expression, the value of this particular expression. Okay, and at the end we write here the end case. So if it is like this, that is this particular expression is when if this is the choices. Okay, so here you are having the choices. Okay, so if the value of this expression evaluates to this, then this particular sequential statement will be executed. Okay, so that is nothing but your branch 1. If the expression evaluates to this second choices, then the branch 2 sequential statements will be executed. Okay, so like that. So you can have any number of branches like this. Okay, so you can specify any number of when clauses, and you can specify the values for this particular expression. Okay, whereas if it is when others, that means if none of the choices are matching for this evaluation of this particular expression, then this sequential statement will be executed, which is the last branch. Okay, and then it is the end of the switch case statement. Okay, so you can see here that either the sequential statement in the branch 1 or sequential statement in the branch 2, if like that, if many are there, then any one of this sequential statement will be executed, or if none of the choices matches with the result of the expression, then the last statement, which is when others, will be executed. Okay, writing of this particular when others is again optional. So optionally you can have this, and if you do not have this particular statement, and if none of the choices matches the result of expression, evaluating this expression does not match with any of these particular choices, then no no sentences, no branch in this particular case statement will be executed, and the execution will simply begin to the next statement after this particular case statement. Okay, so let us see the example of this particular statement. Okay, so this is the syntax, and this is one example of the case statement. So first of all, yes, any problem? Yes, yes.
Sir, where we execute this program? Which compiler we should use for this?
For this, you need to use simulator. Okay, so there is a VHDL simulator. You need VHDL simulator for this. Okay, so actually, for this particular simulator, we have there in the department, but the size required for that is more. Let us, if any online simulator is available, I will let you know. Okay, so for now, you need to learn the syntax, and you need to execute it manually. Okay, so for the simple programs, you can execute it manually, and I will let you know if any online tool is available for executing this particular program. Okay, so in the beginning, the programs, they are very simple programs. Okay, just like we have seen now the program for the NOR gate, or the program for implementing some other function like that. Okay, so in the beginning we shall see simple programs, and later on, when we go for complex program, then in that case you would like to execute it on some other tool. Okay, so I hope some online tool is available. I will let you know in the next class about that particular online tool. Okay, but I hope if you understand the this particular syntax, then you will be able to manually execute this particular statement, isn't it? Because already you are acquainted with the C language, you have executed the C language programs. So understanding this particular syntax will not be a problem, even if you immediately do not go for execution of the program. Uh, am I right, or it becomes difficult for you to understand this program without going for the actual execution?
Difficult, sir.
Huh?
Difficult,
it is difficult.
Sir. Syntax are difficult, sir.
Because the syntax is little different. Once you are familiar with this particular syntax, then you will find that this syntax is not that much difficult. Okay, because you are not yet familiar. So if you keep on looking at this particular syntax, so then it will not be difficult. Okay, for example, just now we have written a complete program here. Okay, so this is the program for the NOR gate. Okay, so what you need to understand is that two constructs you need to write. Okay, so the first one is the entity construct. Okay, this one, and the second one, this architecture construct. Okay, in the architecture you have to write the process. Okay, so these three things you need to understand for writing any of the program in VHDL as far as the behavioral model is concerned. Okay, so when you are going for the behavior model, you need to know this particular construct. Okay, once you know this, then the if statement, for statement, while statement, they are similar. Okay, like here the case statement is there. Okay, so though the case statement is not exactly same, but it is similar. Okay, you understand the execution of the case statement in C. Okay, so in the similar fashion, here you can go for means you will be able to understand this particular case statement. Okay, now look at this. This particular first statement is defined the type. Okay, so what is the type? Weekdays is the type, and is, so we define a set of the weekdays. Okay, so how many values will be there in the weekdays? There will be 7 values, that is Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Okay, so this is very similar to the enumerator data type that you use in C. Then we have used another type here, that is dollars is range 0 to 10. Okay, so dollars is another type and its range is 0 to 10. That means essentially it is integer, but integers only between 0 and 10. So is the set for this particular, or is the type, that is dollars. Okay, then we create two different variables. First variable is day. So the uh, day variable is of the weekday type. Okay, this particular type. Then another variable is pocket money. So if the pocket money is of the type dollars. Okay, so here this particular program, probably what is it is doing, depending on which is the day, the pocket money given is different. Okay, depending on the day, the pocket money is different. Okay, for example, uh, when day, okay, what is the day? Day is will be having, or it is of the type weekdays. That means what will be the value of day? Value of day can be Monday, value of day can be Tuesday, value of day can be Wednesday, Thursday, Friday, Saturday, or Sunday. So day variable, which is of type weekday, will assume the value one of these seven values. So when the case day is, okay, so what is the value of day? It can be any one of these. Okay, so when value of day is Tuesday, when value of day is Tuesday, okay, so this is how it is to be read. When the value of day is Tuesday, then these sequential statements are to be executed. Okay, so what are the sequential statement? So pocket money is equal to 6. Okay, so the pocket money can take the values from 0 to 10. Okay, then when when it is Monday, or, okay, so this particular symbol, this vertical line is or symbol. Okay, so if it is Monday or Wednesday, then the pocket money is 2. Okay, so this is how the second expression is. Okay, Monday or Wednesday. Then the third statement, when it is Monday to, sorry, it is when it is Friday to Sunday. When it is Friday, that is, it can be either Friday or Saturday or Sunday. So in that case, the pocket money is 7. Okay, whereas when it is others, okay, now which is remained out of this?
Thursday.
Monday, huh?
Thursday.
Thursday is remained. Okay, so if the value is Thursday, so in that case it will not enter any of these particular branches, and it will enter here, and in that case the pocket money is 0. That means on Thursday the pocket money will be 0. Okay, so like this there are 4 different branches. So like this you can implement the switch case statement. Okay, or rather there is no switch keyword. Okay, so the important thing is that there is no switch keyword in case of the VHDL. So that is why the statement is called simply a case statement. Okay, but which is very similar to the switch case statement of the C. The functionality is very similar. Getting the operation of the statement is very similar to that of the switch case statement, but the syntax is different. The syntax is case when. Okay, so case of this particular expression, and when it is equal to this, then these statements are to be executed. Okay, so this is the case statement. uh, so here again we have another program, complete program, and this particular program is for multiplexer. The program is for multiplexer. So already we have seen multiplexer. So multiplexer, what is the multiplexer? Multiplexer is having how many inputs and how many outputs? Single output or single input? Yes? Not audible. Who was speaking?
Single input and multiple inputs.
Multiplexer is, it is many inputs.
Input and single output.
Multiple inputs and single output. Okay. So multiple inputs and single output. Okay, so here how many inputs are there for the multiplexer? You can see here port A, B, C, D and in. That means what are these? A, B, C, D, they are the inputs. Okay, so these are the inputs of this particular multiplexer, that is from A, B, C, D. Okay, and what is the output? The Z is the output. Okay, so here is the Z output. Okay, then there are select lines. Okay, there are select lines. So select lines, they are shown here with what? CTRL. CTRL. Okay, so they are inputs. So the select lines, they are the control inputs. And how it is defined? It is defined as a bit vector. It is defined as bit vector 0 to 1. That means CTRL is an array. So CTRL is an array containing two different elements, that is CTRL 0 and CTRL 1. Okay, so the CTRL will be the group of this particular two lines. Okay, so this will be CTRL. Okay, so CTRL, so it will be having, it is a 2-bit. It is 2-bit, but if we want to refer to the lower bit, then we write CTRL in bracket 0. If we want to refer to this particular bit, okay, so if you want to refer to this particular bit, then we write CTRL in bracket 1, in round bracket 1, so like that. Okay, so but if we write CTRL, then its value, it can be either 00 or 01 or 10 or 11. Okay, so like that. So depending on what is the value of CTRL, if it is 00, what will happen? The first input will be selected and Z will be equal to A. If CTRL is 01, if CTRL is 00, Z will be equal to A. If CTRL is 01, Z will be equal to B. If CTRL is 10, then Z will be equal to C. Whereas if CTRL is 11, then Z, the output will be same as the fourth input, that is D. Okay, so same thing is implemented using this. Okay, so after this entity has been defined, then architecture we define a multiplexer, and the name given is mux behavior. Okay, and we are specifying the architecture of the entity mux. Then a constant is defined here, that is mux delay, and the time is it is of type time, and it is its value is 10 nanosecond. Okay, then here the label is given to this particular process, pmux. Okay, so this is the process. So when any of these value A, B, C, D changes, okay, so when the output will change? The output will change when any of this A, B, C, D changes, or even if this control input changes, the output will change. So here you can see that either A, B, C, D changes or CTRL changes, then in that case this particular process statement will be executed. Okay, so when any of these input changes, then what happens? This particular statements in the begin to end will be executed, whereas temporary variable temp of type bit is used here. Okay, now what is the statement, case statement, how it is used here? Case CTRL. Okay, so say case CTRL, so it depends on the value of CTRL. When it is 00, then temp is equal to A. When it is 01, then the temp will be assigned B. Okay, when CTRL is 10, then temp is assigned C. When CTRL is 11, then the temp is equal to D. Okay, so like this, the temp will take any one of the temp will be assigned any one of this particular A, B, C, D. Okay, and finally, what is assigned to Z is this is the signal assignment statement. Z is assigned temp after mux delay. Okay, so mux delay is 10 nanosecond. That is after any of this particular input changes. So after that, immediately this will be evaluated. Value of temp will be evaluated, and after 10 seconds of that, Z, that is the output, will change, and it will change according to the change in the input. Okay, so this is how is the implementation of the, or this is the VHDL program for a multiplexer. Okay, have you understood this particular program? Understood this program? Yes, you can use your chat box to reply. No replies, that means you are facing some problem. Is it that? Am I audible? Hello, students.
Yes.
Have you understood the program? The program was for the multiplexer. Hmm? Or is it that after you had lunch and now you are feeling sleepy? Is it that? Hmm? Yes, let me check. You understand that this syntax is new to you. Okay, so once you are acquainted this particular syntax, then there won't be any problem. Okay. Yes, Shruti, unmute yourself and let me know feedback from you. Shruti Pote, or are you there? Shruti, are you not there? Yes, Nikita. If Shruti is not there, then we shall. Should I remove Shruti if you are not there? Yes, Nikita, unmute yourself.
Yes, sir.
Understood the program for the multiplexer and for the NOR gate, two
Yes, sir.
programs. Yes.
Yes. Yes.
So immediately it may not be means you may not find it very easy because already you have been writing C program, so it may not be as easy as writing the C program, but you need to be familiar with this particular programs. Okay, you need to be first familiar with the syntax of VHDL. Okay, now just 2 days you have been known with the syntax of the VHDL. So in the beginning, you will find little difficult to understand the program immediately. Okay, but once you are going through the various program, okay, so for this purpose, what is required? You need to go through the various programs. Okay, you need to write now. I have given you the program for NOR gate. Now convert that particular program to NAND gate. Okay, so convert that particular program for some other gate, okay, exclusive OR gate, or you write some draw some circuit. Okay, for example, now write the program for half adder. Okay, so the half adder will contain more than one gate, so in that case you need to write more number of statements. Okay, so in tomorrow's lecture and day after tomorrow we shall be slowly writing the programs, and from these you will understand the syntax of VHDL. Okay, but what is required is that you must practice this particular syntax of uh, the the VHDL. Okay, so
Okay, sir.
uh, hmm?
Okay.
So do you have another lecture, extra lecture now?
Yes, sir.
Which one? At what time?
At 2 o'clock, UHDP lecture.
Okay, at 2 o'clock it is there. Okay, so I wanted to finish up with this particular loop statement. Anyway, I feel that you are feeling saturated. So let us see. We shall defer this particular discussion of the loop statement, which contains the for and while. So that we shall see in tomorrow's class. Okay. So tomorrow morning at 8 o'clock we shall meet, and then we shall consider, or we shall see those particular statements. Okay. So, but be comfortable and be confident that if you are able to write C program, then there should not be any problem writing the VHDL program, or there should not be any problem understanding the VHDL programs. Only the thing is that you need to work. Okay, so you need to understand the syntax of this. Okay, I expect that you read this particular book of J. Bhaskar. Okay, I am taking all examples and the description from this particular book only. Already, soft copy of this particular book I have given to you. Okay, let me show once again the uh, the front page of that particular book. Okay, actually this is not the front page, it is the first page of the copy that I have already uh, sent to you. Okay, so I hope this particular uh, copy is available to you. Soft copy, do you have, all of you have this soft copy?
Yes, sir.
Okay, so you
Yes.
can refer to this. So for the purpose of reading, you can refer to this, okay, and you can compare the examples which are there in the slides with the examples there. They are the same examples. For the added description, you can refer to this, or you can replay the part of the this particular lecture so as to understand if you are not getting something. Okay, so we shall stop here and we shall meet tomorrow morning. Till then, bye.
चंदू लेफ्ट कर चंदू
तू तू है ना तू है
लेफ्ट कर बैठ कर
सुधरा माने भाई हेलो माने भाई
बोल ना भाई चंदू
भाई फुला पे तला सुना बाबू ने
ए नाही रे भाई
भाई बस खाता
अरे भाई त्याचे डोळे सुजले फार माहितीये का रात्र दिवसाचा करतोय तो पूर्ण भाई मी काय तुला काय व्हिडिओ कॉल केलता तुला तू मला पाहिलं अरे भाई आपण तुझं डीपी पण सांगू शकतो एक्सपेक्टेशन खोटे असू शकते ते
बाबू
चंदू सांग रे
भाई बस खाता नहीं पैसा दे
नाही रे भाई जरूर जाते की नाही लेफ्ट कर चंदू लेफ्ट कर पटकन तुझीच वाट बघतोय मी
अरे भूषण सुधरा आता
बर बाय
बर शिवांगी लेफ्ट वर शिवांगी हेलो बंगी लेफ्ट मार बंगी